So for half angle, we're trying to determine what angle on our unit circle can we divide by 2 and get 22.5. So what's an angle that is on our unit circle that if we divide by 2, it's going to give us 22.5? 45, or pi over 4. So if we take 45 degrees, so we're going to take the sine of 45 degrees over 2. That's what we're going to do in order to get the 22.5. So the other question we want to ask ourselves before we get started, what quadrant is 22.5 in on our unit circle? So if the angle 22.5, what quadrant would that fall in? That would fall in quadrant 1. And in quadrant 1, sine is positive. So this angle, this is in quadrant 1. And in quadrant 1, sine is positive. And the reason why that's important is when you look at your half angles, does everyone see the half angle identities on your purple paper? You can cross out product to sum and sum to product because we're not covering that. So half angles is it. That's our last identity, and then we'll start getting ready for our test, which is next Tuesday. So do you notice how they have, some of them have a plus or minus in front? So if you're using one of these 3, you have to figure out if it's positive or negative based on the quadrant that it's in, okay? So because 22.5 is in quadrant 1 and sine is positive, I know that I'm using this identity and it's positive, it's not negative, okay? So let's go ahead and set it up. So I have the sine of 45 over 2, and that equals positive, so it's not plus or minus, it's positive because we're in quadrant 1. And then that identity says that we take 1 minus the cosine. So even though we're trying to find the sine, the identity tells us to take 1 minus the cosine of the angle that we're dividing in half. So that would be 45 degrees. That's all over 2. So now go to your unit circle. You probably know this by heart at this point though, but what is the cosine of 45 degrees? So we have the cosine of 45 degrees is root 2 over 2. All right, so we have, this is positive, and we have 1 minus root 2 over 2, and that's all over 2. So I will say this, half angle identity is a lot of steps, but it's the same steps. So once we go through these steps the first time and you see the steps, it's the same steps. So after we figured that out, we need to simplify the numerator. So we have 1 minus. So how do I need to write that 1? Because I can't subtract it if I have a different denominator. So I'm going to write it as what? 2 over 2. Okay, so I'm going to write that as 2 over 2. And then that would be minus root 2 over 2. And that's all over 2. So now that I have a common denominator, I can bring this together as a single fraction. So I'm going to write this a little different. So So my numerator, this becomes 2 minus root 2 over 2. Actually, I'm going to write that in different color. So my numerator is 2 minus root 2 all over 2. And that's divided by, I'm going to write this with the division symbol now, because when you have a fraction, you know that's division. That's divided by 2. That is what's going on under my square root. So what do you think I'm going to do next here? Got to do the keep, change, flip. So let's do that. Okay. So I have positive, and then my numerator is 2 minus root 2 over 2. And that's being multiplied by my denominator, but I flipped it. Keep, change, flip. So now we're ready to multiply straight across, because I'm trying to simplify this down to one single fraction. So when I write that, when I multiply 2 minus root 2 times 1, that's just the same thing. It's just 2 minus root 2. And then that would be all over 2 times 2. And 2 times 2 is 4. Okay, we're almost to the end. So whenever you take the square root of a fraction, you separate it. We square root the numerator and we square root the denominator. So it becomes the square root of my numerator all over the square root of my denominator. And my denominator can simplify. What is the square root of 4 going to be? It's going to be 2. And you have reached the end. So my final answer, and because it's positive, you don't really, when it's positive, we don't necessarily need to put that plus sign in front. It's only important when it's negative that we keep that in front, but I'm just keeping it in front. So my final answer would be the square root of 2 minus root 2 all over 2. And I don't have a square root in my denominator. I'm happy. I reached the end. And that's example 1 for our half angle. There are 6 examples altogether. We're only doing 3 today. Example 2 for our half angle, another sine, except this time it is 165. And the reason why we tell you is because, for example, if it just says sine of 165, well, you could do that with sum and difference. You could take 120 plus 45 and get the answer. So it will tell you which identity that we want you to show. So the first question is, what quadrant is this in? 165. Okay, so this is in quadrant 2. Do you agree 165 degrees? So 165 degrees is in between 90 and 180. Is sine positive or negative in quadrant 2? Positive, okay. So I'm going to write that down so I know I'm in quadrant 2. And I also know that sine is positive. So when I'm using this identity, I'm still keeping that plus sign in the front. It's positive. So what angle am I dividing by 2 to get to 165? So you can just take, if you're not sure, you just take 165 plus 165. So 165 times 2 is 330. So that means half of 330 is 165. So I'm going to use, to find this one, I'm taking the sine of 330 over 2. So when I take the sine of 330 over 2, it's positive because we're in quadrant 2. So it says 1 minus, and I'm going to use the cosine of 330 again, or the cosine of 330, and that's all over 2. So what is the cosine of 330? The cosine is root 3 over 2, and it's positive, right? Because we're in quadrant 2, and quadrant 2 cosine is positive. So that would give us positive, okay, so then we have 1 minus root 3 over 2. All over 2. So again, it's a lot of math, but it's the same math steps. Literally the same steps. So what was my next step? In the numerator, what do I have to do with this 1?
You have to do 2 over 2.
Yep, right, that is 2 over 2. So in my numerator, I have 2 over 2 minus root 3 over 2, and that's all over 2. So I'm going to split it apart and make it 2 fractions. So my numerator is 1, because I have a common denominator, I can bring this together. 2 minus root 3 over 2. That's divided by 2 over 1. Go ahead, do your keep, change, flip. So when I do my keep, change, flip, that's what I have. So now I'm ready to write that, multiply straight across. So when I multiply straight across, I have 2 minus root 3 all over 2 times 2, which is 4. Okay, when you take a square root of a fraction, you square root the top and you square root the bottom. So when I square root the numerator, it becomes the square root of 2 minus root 3, and that's all over the square root of 4. So I'm breaking it apart. The top part cannot be simplified, so we're going to leave that alone. And fortunately for us, the denominator can be, and we don't have to do any more steps. So this would be my final answer, and it's positive because we said we're in quadrant 2, and that would be it. It's easier than what? You think so? Half angles, usually, that's just a lot of work. So usually, you know. Any questions about example 2? All right, last one. Go ahead and copy it down. Again, we're doing half angle, and this time we're going to do cosine 7 pi over 12. So go ahead and copy that down. So there's a lot of different ways to figure out what the angle would be. But I need to figure out what angle am I dividing in half to get to 7 pi over 12. So what I'm going to do is take this 7 pi over 12. I'm just going to add it. If you take 7 pi over 12 plus 7 pi over 12, you get 14 pi over 12, which reduces to 7 pi over 6. So what that tells me is half of this angle is going to give me 7 pi over 12. So I'm going to take half of 7 pi over 6. So in order to find this identity, I'm going to take the cosine of 7 pi over 6 all over 2. And that's how I'm going to do that. So 7 pi over 6. Okay, so let's do it. Okay, so we have the cosine of 7 pi over 6 divided by 2. So now we're doing the cosine half angle. So look for cosine half angle. So for your, let me pause for a second. What quadrant do you think 7 pi over 12 is going to fall in? So let's talk about that before we get into our identity. So the unit circle goes 0, and then you have a half, then you have a whole, and then you have 1.5, and then you have 2. So fractions are a little bit harder because we have to figure out where would 7 over 12 fall. So first of all, I know that 7 over 12 is not an improper fraction because 7 pi over 12 is less than 1. 7 over 12 is less than 1. So because it's less than 1, I know that I'm not in quadrant 3 or 4. So now what you have to figure out is 7 over 12 more than 1/2 or less than 1/2? Where do you think 7 over 12 would fall? It would fall in 2 because half would be 6 over 12, right? 6 pi over 12 would be half. And pi, this would be 12 pi over 12. So 7 pi over 12 falls between 6 and 12. So it would be over here. So we are in quadrant 2. Okay? We're in quadrant 2. And in quadrant 2, is cosine positive or negative in quadrant 2? What is cosine in quadrant 2? Is it positive or negative? It's negative. So I know that I am in quadrant 2. And I know that cosine is negative, and that's important. Okay, so now let's get to it. So when I write my identity, I'm going to keep the negative because that identity says positive or negative, but we are in quadrant 2, so it's a negative. Put your negative in the outside. And then we have the square root of 1 plus the cosine of 7 pi over 6. That's all over 2. So go to your unit circle. Figure out the cosine of 7 pi over 6. The cosine of 7 pi over 6 is negative, right? So you have plus a negative. So I'm just going to change that to a subtraction sign instead of an addition sign. Since the cosine is negative, 1 minus root 3 over 2. And that's all over 2. All right, so let's write that as our common denominator. So I have a negative on the outside. So what I'm going to end up having is 2 minus root 3 over 2. So I skipped a step. I skipped the step where I wrote that 1 is 2 over 2. And I divide that by 1/2. All right, take a moment and see if you can simplify it to the end, and then we'll go through it together. I skipped 2 steps instead of 1 step, so let me go back. That's divided by 2. Okay. All right, so now you all finish it out. Do your keep, change, flip. All right, so next, okay, so there we go, multiply straight across, and we have, in the numerator, we have 2 minus root 3, and then in our denominator, we have a 4, and when we square root top and bottom, oh, let me put that negative in front, can't drop the negative. Negative has to stay because we're in quadrant 2 and sign is negative. So my final answer is negative. And then we have a square root of 2 minus root 3. And that's all over 2. And that is your final answer. All right, go ahead, take out homework 12. I want to look at one of the questions in homework 12 real quick. A lot of people are asking me this question about homework 12, so let's look at number 3. Can I borrow your paper real quick? Let's look at number 3 real quick for homework 12. So for homework 3, it tells you that the sine of theta is 1/5. It gave you the interval, which is quadrant 1, and it wants us to find the cosine of 2 theta. Okay, there are 3 choices. When you look at your purple paper, there are 3 different choices that you can use to find the cosine double angle. But there is a choice that only uses the sine. So if I can find it without getting cosine, then that's the easier step to use. You want to think about what you're given and where you're trying to get to. So I can find the double angle cosine using what they gave me. So I don't need to do the Pythagorean theorem to find the cosine. That's not necessary. Now you can do it that way, but that way it's going to be a lot more work to get to the final destination. The easiest way to do it would be to use cosine of 2 theta equals 1 minus 2 sine squared. So how about we use that one? And for that one, all I would have to do is substitute in my sine, which they gave me, and that's 1/5. So you finish it from there. Do order of operations and figure out what that would simplify down to. But a lot of people who came and asked me for help, they started off by finding the cosine of theta, and they were trying to use the first one. And that one, I mean, again, if I can get to it with doing less work, then how about we do it the easy way? Does that make sense? I mean, you can find the cosine, but the cosine of theta ends up being like 2√6/5. And I mean, why? Why use this if I don't have to? Let's just use this one. Follow order of operations. You're going to square PEMDAS. Square and then you're going to multiply, and then you're going to subtract. Write that one with the common denominator.